Okay, what if I told you that one single, ordinary day on the calendar is, well, secretly the key to understanding modern math? Seriously, we're about to take a trip that spans over 1,000 years, and it's all tied together by this one incredible date.
And that date, it's April 13th. Now, I know what you're thinking. Just another day, right? But in the math world, oh, it's a huge deal. So let's dig in and find out why.
You see, across centuries, all over the globe, some truly brilliant minds were either born or passed away on this exact day. And each one of them, they left a mark on our world that we still feel today. So let's meet them, shall we? So, let me ask you something. Have you ever really, truly wondered why we use x in math? You just accept it, right? X is the unknown number. But who decided that? And why don't we have to draw like a little box every time we want to solve for an unknown area anymore? Well, the answer to that question takes us all the way back to April 13th, 953, and it starts with a man named Abu Bakr al-Karaji. Okay, so this is where things get really cool. Before al-Karaji, algebra was literally chained to geometry. I mean, if you wanted to talk about x squared, you had to physically draw a square. But he came along and was the first to say, wait a minute, no, x is just a thing, it's a number. An unknown, and we can add it, subtract it, multiply it just like any other number. And that simple idea, it completely set algebra free. It's why we can do what we do today. It's like he gave numbers a language of their own. For the first time, they could tell their own story without needing pictures to explain everything.
All right, so we're staying on April 13th, but we're about to jump forward in time, a long way forward, almost 800 years, in fact.
Think about this for a second. How on earth do engineers build these massive canals to control rivers? And on the other hand, how do we predict the exact motion of our planet as it spins through space? I mean, one is about flowing water, the other is about planets. What could they possibly have in common? Well, the answer shows up, you guessed it, on April 13th, 1728, with the birth of a man named Paolo Frisi. So Frisi was one of those guys whose brain just worked on another level. He looked at the real world and applied math to everything. He took Newton's brand new theory of gravity and used it to figure out stuff like the actual shape and motion of the Earth. But here's the kicker. He used those same mathematical ideas to become an expert on hydraulics, designing canals, controlling rivers, that sort of thing. And that's what was so amazing about him. He basically saw that the universe speaks one language, math. The same rules that govern the spin of a planet were at play in the flow of a river. It's all connected. Okay, let's keep moving on our timeline. Same date, April 13th, but now we're rocketing into the modern era. All right, here's a real mind bender for you. How can modern computers solve some of the most complex problems imaginable? I'm talking designing medicines, creating movie special effects, by basically just guessing? Like playing a game of chance millions of times. It sounds totally backward, right? How can you get a precise answer from pure randomness? This crazy idea brings us to our next stop, April 13th, 1909, and the birth of a man who absolutely changed the game for modern computing, Stan Ulam. So get this, Ulam, while working on some seriously top-secret stuff, comes up with his technique called the Monte Carlo Method. The idea is brilliant in its simplicity. If a problem is just way too hard to solve head-on, don't. Instead, you run a simulation of it thousands, even millions of times, using random numbers. And then you just look at the average result. It's like finding the answer by seeing where the darts land most often. And today, this method is everywhere. It's how we forecast the weather, how Wall Street models the market, and yeah, it's how they make those jaw-dropping special effects in movies look so real. That was his genius move. He figured out that you don't have to fight chaos. You can use it. He discovered that randomness itself could be a tool to find the answers hidden inside all that complexity. So, one date, 3 incredible minds. But believe it or not, our April 13th story isn't finished. There's one more person we need to talk about. And this one changes how we all learn math. I want you to imagine something. What if learning math wasn't about memorizing rules from a dusty old textbook? What if instead it was about discovering those rules for yourself, using real-world objects, your hands, your intuition? Well, that revolutionary way of thinking about education, that was the life's work of the amazing Emma Castelnuovo. And in what feels like a perfect circle, she passed away on our golden date, April 13th, in 2014. Emma Castelnuovo completely flipped math education on its head. Her whole philosophy was, let's not start with the boring abstract rules. No, let's start with curiosity. Let's start with real stuff you can touch and feel. She saw that mathematical rigor, the really precise stuff, that wasn't the starting line. That was the destination you reach after you've played and explored and discovered things for yourself. It made students feel like actual mathematicians, not just human calculators. Simply put, she believed that every single student could be a math discoverer, not just a math calculator. And that's a powerful idea. So there you have it, a journey across 1,000 years of breakthroughs, all happening on April 13th. We've met an ancient algebraist, a cosmic engineer, a computational pioneer, and a revolutionary educator. So what's the connection? What's the one thing that ties all four of these incredible people together? It turns out they were all asking the same fundamental question: what is the pattern hiding inside the chaos? Every single one of them was a pattern finder. Al-Karaji saw the hidden rules in numbers, separate from shapes. Frisi saw the same patterns in a river and a planet. Ulam found patterns in what looked like pure randomness. And Castelnuovo? She gave us the tools to find those patterns for ourselves. They all looked at this complicated world and asked, where is the simple, beautiful idea hiding just beneath the surface? So here's my challenge to you. The next time you're just going about your day, look around. What patterns do you see? They're everywhere, in music, in nature, in the way traffic flows.